This is the molecule of tetracycline. As you can see, it has a quite complicated structure which makes its synthesis a really hard task. You might ask yourselves, why is this molecule important? Well, tetracyclines are a group of broad-spectrum antibiotics characterized by the four rings that compose their carbon nucleus. These antibiotics are classified in four groups due to slight modifications in the non-critical side of the molecule. We know these products by the names of teramycin, tetracin, zomycin, and panmycin. The function of this antibiotic is to bind to the 30S ribosomal subunits in order to prevent the formation of the ribosomal complex and stop the protein synthesis. This will lead to the bacteria's death. Because of its importance, it is imperative to synthesize it in large quantities. The chemical approach is possible, but the introduction of functional groups to the carbon nucleus may result in difficult and give an unstable product. Therefore, another approach must be made. With the insights of biotechnology, the production of the antibiotic is possible using a microorganism as a biocatalyst. Streptomyces aureofaciens, using a saccharose carbon source, can synthesize the molecule during its metabolism as a secondary metabolite. This bacterium can be obtained from one of the international collections of microorganisms. The strain will be provided lyophilized, so there must be a careful process of reactivation before the fermentation. The bacterium must be inoculated in air slants and then inoculate spores in agar plate and petri dish, then inoculate spores again in an early flask and place it in a shaker for 24 hours. Only then the microorganism can be placed in a fermenter. The fermenter must have special conditions: pH between 5.8 and 6, temperature at 28 degrees Celsius, saccharose as carbon source, low phosphate concentration, and trace elements. The fermentation must go on for a period of 60 to 65 hours. Once the process is completed, an engineering challenge is observed: the purification of the antibiotic. It can be solved by several ways: filtration, ion exchange, absorption, chemical precipitation. For this particular process is commonly used filtration. It is important to mention that different morphological shapes can result depending on the rheological behavior of the fermentation broth, but the rheology will not be a critical issue for the production of the antibiotic. The ultimate engineering challenge to be solved is biosafety. A lot of measures must be taken in order to ensure that the product will be clean of contamination. All equipment must be sterile, and the staff must follow the guidelines of the Biosafety of Microbiological and Biomedical Laboratories Handbook.